Howdy, my name is Landon, and this is Progress. So what is Progress? All right. We wanted to make this project to kind of help go across data for literature review with the hopes of being able to extract future directions from a large selection of texts. I'm going to read this verbatim. Progress presents a novel machine learning solution to tackling the mountain of information at our fingertips, leveraging keyword searching algorithms and an integrated OpenAI assistant to streamline the process of literature review. So the data set that we're going on, I got this summer, the majority of it, not the entirety of it, but based on tetrahedral DNA nanocages. Over the summer, I was able to spend my time in the India Institute of Technology at Gandhinagar. They had me doing like cell culturing, all of that, and a literature review, which I thought, why can't we automate this? This is such a tedious process, and you're reading the same paper over and over and over again. But if you can just extract the future directions from all of that, we can just simplify everything that all of the past researchers know and know that we need to learn down into one teeny little box. And from there, then we can actually have future research. Another caveat that we were kind of trying to figure out is how we can make this academically feasible, being able to cite the papers. So the final database is going to have the name of the paper, the DOI, all the information that you would need to be able to go back and figure out where those future directions are coming from, and then read the papers that are actually applicable to what you want to do. So how are we going to approach this? Model architecture that we did is based on most research papers, you're going to get them as a PDF. So we just tried to go strictly for PDFs. Extracted the PDF data, then parsed it through keyword searching, then verified with a secondary machine learning algorithm, and then finally parsing to OpenAI through their new assistance program, their beta, and I will explain that soon. So at the very beginning, we've got the PDFs. We want to splice, get the text. We're going to have to clean it up because there's a lot of invalid characters when you get from PDF to text. And then we're putting it through a logic gate, just saying, like, if this keyword is in this little snippet, then say it's a 1. It's possible that it's got a research. We wanted to prioritize false positives because we know that we can filter them out later on. And I'll talk about that filtering. The GPT assistant. So it's basically just you give it one prompt and then you can feed it a lot of menial tasks. So the task is to analyze text inputs extracted from research papers for future research directions. We gave it like in a little example what we wanted it to format it like, and then if there's no query for future directions, it's just going to respond with a 0. This makes it so I can parse the Boolean at the very beginning, just have it tell us whether or not there's actually a research direction. And then if there is a research direction, it's going to respond with what the actual subjects of those research directions are. And that can be parsed into a little array on the side. So the statistics for once we parsed it in, the total number of entries, there's 300K lines of text, but only roughly 1,500 of those actually had positive for research advice from the keywords. Once we parse it into the OpenAI, only 665 of those truly had that. From what we can tell, there was 273 of those that had errors. As statistics, that's going to be a true positive rate for the keyword search of 45%, and a false positive rate of 55%, and then a roughly 19% GPT error, going as in language model. It's a pain, but through prompt engineering and better selection of texts, we can probably lower that error in the future. So example output, I'd grab this just randomly from my little data set. Further research should reveal blah, 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 and then it gives the subjects, and then the subjects get returned as the effects of charge properties on iodine capture, development of POPs with specific charge, and that goes on for all of the data points that were positive. So large language models are key for this. We also wanted to have that secondary verification. So the idea was that with the keyword search, it's going to have a lot of false positives. We want to filter it out before we put it into OpenAI because the OpenAI costs money. And in the long run, that's going to cost a lot. So we used BioBERT, which is a biomedical data set from PubMed that was back in, I think, 2010. And they provided us a vectorization platform. So we can just apply that to our data set. And then we realized that there's only the 665 data points that were positive, but we had, I think we culled down to roughly 180,000 lines of text just through dropping the papers that didn't have any future directions. But that's still a pretty large disparity. So to fix that, we used PCA, which just decreases the size of the vector, kind of makes a more broad contextualized version, but not actual contextualization, as I'll talk about later with LLMs. But secondarily, the SMOTE for increasing the minority class to the same size as the majority class to try and like decrease the disparage, and then having the data based on where it is in the text. So that was an idea Professor Hanks actually had. But if we cut the first half of the paper, because there's usually no future directions in that, it makes it a lot faster, and it does increase the ROC because there's less data. But the caveat is that any like input from that first half will be flagged, as this is a semi-anomaly detection algorithm. So we kind of wanted to shy away from that. We will toy with it most likely in the future. I'd like cross those out because in our final model we did not really keep that. So first attempt was the isolation force anomaly detection, which is an unsupervised method or semi-supervised method. It did not work as well as we thought it would. Has a 0 anomaly, so true positive rate of 0. Same for the local outlier factor. That one's truly unsupervised. Then we went with neural networks. So that one was a lot better, but it's still not as good as just the keyword search with only a TPR of 9%. There's a long ways to go on that side. I feel like it's still not quite what we would need it to be. At that point, we will probably have to build our own large language model specifically for text, for biomedical texts. It's the more advanced statistics. We were trying hyperparameter tuning with that. We were able to get the ROC curve up from 9 to a 0.93. Excuse me. Shows best activation with ReLU, with a true batch norm, drop rate, L1 regularization but no L2 regularization, pretty slow learning rate, high epochs with that, and low neurons per layer for the secondary layer, and then Adagarad for the optimizer. That resulted in like a 99% accuracy, but accuracy is not really a good metric for this because of the fact that we're mainly looking at the true positive rate. So to finish out, we've got a call to action. As academics, we need to move publications toward open source with the goal of automation of technological advancement. Like I said earlier, our main problem was getting the PDFs. We ended up using Elsevier. Elsevier is amazing. They allow you to have 100 downloads per day, and then we had all of our friends download 100 downloads, and we were able to get a lot of papers really quick. But we didn't realize this until later on because of the sparsity of it. They don't really advertise it. But other publishers, we would like them to follow suit, maybe some form of API that we can download mass papers from. We toyed with the idea of using Sci-Hub, but there's a lot of moral dilemma on that aspect. I am all for the freedom of knowledge, but I am also all for morals. So finishing out, with the right mindset and access to data, we can greatly accelerate our efforts through advanced data processing tools we have access to today. With tools like OpenAI's LLM, possibly Progress LLM once we develop it, we would hope that we can really get faster. Speed is the name of the game. When there isn't funding, we want to keep this open source. We can have it be free. Knowledge, progress, that's what we want. Thank you.